All right, so last video, let's just talk quickly about empirical rule again and make sure we're comfortable with these types of questions. So I'm going to leave that diagram up there for right now. And I'm going to go back to this question about pollution and let's see how it applies. So they told me for this distribution that the mean is 35.9 and the standard deviation is 11.6. So I'm going to draw a diagram specifically using that information for the distribution. So we've got, let's see, so we've got a mean of 35.9 is going to go right in the middle. They told me the standard deviation is 11.6. So calculate one below, one above. So take your calculator out, do this with me and practice it. Take 35.9 and minus 11.6. And so one below gives me 24.3. And then on the other side, do 35.9 plus 11.6. 35.9 plus 11.6. On the other side, I get 47.5. Now, 2 below, so you're going to do 24.3 minus another standard deviation. So 24.3 minus 11.6 puts me at 12.7. On the other side, do 2 standard deviations above the mean. You're going to do 47.5 plus 11.6. And so on the other side, that puts me at 59.1. So what you want to pay attention to is that here's your mean. Here's 1 standard deviation above and below, and then 2 standard deviations above and below is between 12.7 and 59.1. Well, using the empirical rule, 2 standard deviations above and below the mean is a span of 95% of your data. If you go back to this graph over here, and if you add 13.5, 34, 34, and 13.5 again, you get 95 exactly, okay? And so you can use those little subsections to figure out any range they might potentially ask. Look at the next question. They want you to go from 24.3 to 47.5. So that would be this subsection and this subsection. Happens to be 1 below, 1 standard deviation above. So that would be 68%. You could also have just added 34 and 34. Part C says 35.9 and 47.5. So that would be this little subsection right here. We'll go back to your master graph here, and you can see that that would be 34% of the cities in your sample. D says less than 12.7. So think about that. Less than 12.7 is down here. Well, remember, this is 2 standard deviations below the mean. That's right here. So less than 2 standard deviations below is this little subsection, and that would be 2.5%. This is why I want you to have this particular diagram on your paper so you can figure out any range of intervals they ask about. And then E says the pollution index for New York in 2017 was 58.7. Was this unusually high? So anything outside of 2 standard deviations we consider to be unusual. So if you're at 58.7, that means you're up here. Well, remember, 2 standard deviations above was 59.1. 47.5 is only 1 standard deviation above. So if you're at 58.7, are you still within 2 standard deviations? The answer is yes, you are. So no, you are not unusual. Okay, and the reason is because you're still within 2 standard deviations of the mean. And that's our cutoff for unusual values. Let's pretend instead of 58.7, they had asked about 60.3. Would that have been unusual? Yes, it would have, because that would have been past 59.1, which was 2 standard deviations above the mean. Okay, and then the next thing I want you to be comfortable with is calculating z-scores. So z-scores give us a way to calculate how many standard deviations a particular value is above or below a mean. And so Make sure you know the formula for z-scores. The formula, and this is something else I'd put on my index card, is x minus mu divided by sigma, okay? So it says the dot plot shows the heights of college women where the mean is 64 and the standard deviation is 3. What is the z-score for somebody who is 58? All right, so then to calculate that, we would do 58 minus the mean of 64 divided by 3. Okay, so that would be negative 6 on top divided by 3 gives me a z-score of negative 2. Z-scores that are negative mean that you are below what the mean is, and that should make sense because 58 is certainly below 64. Positive z-scores are above the mean. That's the difference. Now, they gave you this graph. They didn't have to do that, but I do want you to see that negative 2 is right here, and that does correspond to a height of 58. So we did calculate it right. When the values are exact, a certain number of standard deviations, 3, 6, 9, for example, because standard deviation is 3, then the z-scores are going to be nice whole numbers. But if the z-score had been anything else, like let me say that again. If the value they asked you about had been in between, like let's say they had asked you about a height of 59 inches, for example, then the z-score would have been 59 minus 64 divided by 3, which would have been negative 5 over 3. So, of course, 5 divided by 3 is going to be a decimal. That would be negative 1.6 repeating, so 6.7 if you round it. So this formula will allow you to find a z-score for any value, no matter where it is in the symmetric distribution. B says, what is the height for a woman that has a z-score of 1? I think the easiest way, we're not going to expect you to go through the algebra for this question, but the easiest way to get this would be to look at the graph. 1 would be right here. That would correspond to a height of 67, and that should make sense because if the mean was 64, add 1 standard deviation of 3 above that puts you at 67. A z-score of 1 means that person is exactly 1 standard deviation above the mean. C says, Sarah's height corresponds to a z-score of 1.4. How would you interpret this? Well, it's positive, so that means she is above the mean. So we would say her height is exactly 1.4 standard deviations above the mean of 64 inches. By the way, is that unusual? No, it is not, because she is within 2 standard deviations of the mean. Negative 2 to 2 for z-scores would be considered normal. Or I shouldn't say normal. It would be considered standard, not unusual. So if she had had a height with a z-score of 2.3, that would have been unusual. But her height was only 1.4, so that's considered pretty standard, pretty common. It's within 95% of all heights. And then D says the standard deviation for the height of college men is 4.25. Do college women or college men have greater variability? Well, the standard deviation for women, the S for women was 3. The S for men is 4.25. So men have greater variability because they have a higher standard deviation. Remember that standard deviation talks about spread, how much variability there is in the data. So the higher the standard deviation, the more variability you're going to have. I'm going to skip down to number 24, which is on box plots. I may not go through this whole question, but a couple of things I just want to point out. We are looking at comparing 4 different regions here and poverty rates. The West, the South, the Northeast, and the Midwest. And poverty rates, I assume these are percentages by region. So A says, list the regions from highest to lowest median. So the box that is in the line that is in the box tells you the median. So the highest would be over here. So it's going to be south is going to be first. And then the next highest, it looks to me like, is the west. And then it goes northeast and then midwest. So this one corresponds to, I don't know, maybe 16 and a half or so. West corresponds to a little over 12%. Northeast looks to me like it's about maybe 11.5, and then Midwest looks to me like it's around 11. So that's the order from highest to lowest. List the regions by lowest to highest, this time lowest to highest interquartile range. So the IQR is going to be Q3 minus Q1. Now, you don't actually have to compute these when you're looking at the box plots. You just want to look at the widths of the boxes. So Q1 is this end here, and then Q3 is this end up here. So the lowest would be the smallest box, literally. So I would say that would be the northeast. So this one here. The next one, it looks to me like it's a little hard to tell just by eyeballing it. I would say it looks like it's Midwest. And you can calculate the numbers yourself, but it looks like this one goes from about 10.5 to about maybe 13.5. This one looks like it goes from about 15 to about, I don't know, 17. Oh, maybe I'm wrong. Maybe it goes northeast is next. I'm going to change that. I think northeast is maybe the next one. Oops. I think on the test, if there's one like this, it won't be quite subjective. I think it'll be a little bit easy. I'm sorry, not northeast, south I meant. It'll be a little bit easier to eyeball it. But I want you to see you're doing Q3 minus Q1. So I'm going to go south, and then I'm going to go Midwest. And I'm going quickly here because I want to get this video wrapped up. And then I think West has the largest IQR, the largest box. So that one would have the highest variability. Unusual high or low poverty rates, you're going to look for the dots. So notice that the South has one here and the Northeast has one here. So I would say the South and the Northeast. And it could be on the other end as well, but those dots mean you have outliers. D kind of goes along with B, so I'm going to skip that one for now. Same thing with E. Let's look at the 5-number summary. Now the 5-number summary, make sure you remember what that means. That's the minimum. Q1, the median, Q3, and then the max. So in this example, they said the 5-number summary they want you to use the South. So let's go back up. The minimum is the outlier. Don't ignore that, okay? Don't start where that little lower fence is. That just tells you that anything past that is an outlier. But minimum is the minimum. So for the South, the minimum is this dot right here, and I would say it's around 9.5%. So I'm going to go here. I'm going to write my answer up here for this part. So for the South, the 5-number summary, I'm going to go 9.5, and then I'm going to skip this. I'm going to go to Q1 would be here, and I would say that's somewhere around 15. The median is somewhere around maybe 16.5. Q3 would be up here. So I would say around 17.5. Now notice there's no outlier up here. That's okay. That just means this number then is the maximum. So I would say that's around maybe 19.5. Just don't ignore that outlier. A lot of times students will do the 5-number summary and they'll start with this number. Don't do that. If there is an outlier, you need to include that as your minimum, or if it was up here, your maximum. And again, I eyeballed those, so if you look at the answers and they're slightly different, don't worry about it. Remember the test is multiple choice, and we'll make sure the numbers are more obvious, or very obvious, so you won't second guess yourself. All right, last thing, I'm going to skip down to a question on regression equations, and I'm just going to point out that there is some material on Chapter 4, so if you make sure you take a look at question number 30, you've got the equation, the regression equation for your scatter plot here. So make sure you go through this question and spend a little bit of time on this. This is your X, or your independent variable, whatever's attached to the number in the front. And then this is your Y, or your dependent variable here, the number on the left side of the equation, or the variable, I should say, on the left side of the equation. Scatter plots allow us to compare two numerical variables. So take a few minutes on your own and go through question number 30 and focus on calculating the predicted height, which I believe would be question B, interpreting the slope, and then the y-intercept. And that's mostly what we're going to have you look at for Chapter 4. As well as a couple questions where you have to just match up the correlation coefficient with the graphs, and that's the majority of Chapter 4 questions on the test. All right, as always, please send me an email if you have any questions about these or anything else, and I will see you online.